These are the notes for Unit 6, Day 9. And just before we jump into the notes, just a quick announcement. There are no Unit 6, Day 8 notes. So in this curriculum, Day 8 is content that we don't typically cover. So we're skipping from Day 7 right to Day 9. Okay, so just a little review. I'm going to have you stop the video and attempt this on your own. We're not going to do all of these, but just a spattering of them. So stop the video and solve, let's do B, solve by factoring. So remember that solving the equation requires you to factor it. Requires you to factor set equal to 0 and solve. Okay, so stop the video and try question B, and then you can start the video up and see how you did on that solution. Okay, if you're tuning back in, I'm assuming you've attempted question B, just B. We're going to skip these two. They're done the same. Okay, so we have this quadratic, and I'm just going to do a quick star here. So we know that the top is a times c, which is 1 times negative 24, so that's negative 24. We know the bottom is value b, which is negative 10. This is just an x squared with no coefficient, or at least the coefficient is equal to 1. So we know we just have x's up there. So if you look back on your factor sheet, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And since we have a minus 24, minus 10, we know that we have a plus minus combo. And the plus minus combo that makes a negative 10 would be 2 and 12. It would be a plus 2 and a minus 12. So minus 12 plus 2, that's going to give us a negative 10 and a negative 24 when we multiply. So we know that we have x minus 12 times x plus 2, and that, bringing down this, that equals 0. And so we know that if those are the two factors of that quadratic, then if we want the quadratic to be equal to 0, then one of those factors has to be equal to 0. And solving that first expression says when x is equal to 12, when x is equal to 12, that makes this factor 0, which makes the whole quadratic 0. And then solving the other factor says when x is negative 2, that makes this factor 0, which makes the whole quadratic 0. And then A and C are solved in a similar fashion. If you want some extra practice, you can do A and C, and then you could check your answers on the notes PDF in Blackboard. All right, let's try question 2. Question 2 is a completing the square. So again, this is a previous section. So it's asking you to solve by completing the square. So similar progression, right? We're going to factor this, and we want to set this up as a perfect square. So go ahead and complete the square, and then after you've completed the square, then you can square root both sides, and then you can solve each equation. So go ahead and pause the video. We're going to do B again. Let's stick with B's. So again, A and C would be for extra practice. And go ahead and pause the video and try B on your own. Okay, if you're tuning back in, I'm assuming, it's the same. Oh, well, that's okay. I didn't realize these were identical. But let's just see how a different technique leads to the same answer. Okay, so completing the square here is first getting the x and the x squared terms, which are these two terms, the x term and the x squared term. You keep them by themselves on one side, and then move the constant term to the other side. So the first thing we're going to do is add 24 to both sides. So we have 24 here, equals x squared minus 10x. Okay, so this is the completing the square portion. That goes in the graphic below. So we know this is x squared, and we have to take negative 10x and put it into these two spots, and we have to divide it equally. So that means that negative 5x goes in each one of those spots. And that gives us our length and our width of our square. And since this is a square, the length and the width have to be the same. So that leaves x and minus 5 across the width and x and minus 5 across the length. And then that means we can complete the square, right? We can complete the square by filling in this final box. And this final box is negative 5 times negative 5, which is a positive 25. So we know then we have to add 25 to both. We have to add 25 to the right-hand side, and then that gets us a perfect square. And then because we have an equality here, we want to maintain that equality, we're going to add 25 to the left side. And so we can go ahead and do the math on the left side there. That's 49. And then the right side is going to be x minus 5 times x minus 5. If you notice, that is the length and the width of our square model. And then we are going to rewrite that as x minus 5 quantity squared equals 49. And now we can do that square rooting of both sides. And when we square root both sides, we get plus or minus 7 on the left and x minus 5 on the right, and that leads us to our two solutions. So let's take the positive solution first. I guess I don't really have to write the plus. So 7 equals x minus 5. And then we could take the negative solution, which would be minus 7 equals x minus 5. Notice I'm changing the sign on the 7. Right, that's where we have the plus minus from square rooting 49. Okay, adding 5 to both sides. I get x equals 12. And then adding 5 to both sides on this solution gets us x equals negative 2. So these are the two solutions for the quadratic, and notice that matches the two solutions above, 12 and negative 2. All right, we should get the same answer if we're working the same problem no matter what technique we use. Okay, so now talking about techniques, we're going to learn a third technique. And this third technique is the most universal technique, as it works for any quadratic. So that's what makes it really super valuable. And it involves a little bit of messy math, as you can see from the expression below. But it is universal, which is really its big advantage over the other techniques, which aren't necessarily universal. There are quadratics you can't do a star method on, right? This is not necessarily a universal technique. And although this is pretty universal, square rooting this number over here gets messy. But if you notice, this plus minus sort of scenario, it shows up in this equation here. So this is kind of a completing the square type operation. So this is called the quadratic formula. And in the quadratic formula, what we need to identify is these values for a, b, and c. And so the values for a, b, and c go along with that standard form of the quadratic. So that's the standard form of the quadratic. And so a, b, and c can be positive, negative, depending upon the signs in the quadratic. So let's kind of just practice identifying a and b and c. So let's start with 3a here. So a and b and c are always numbers. Keep that in mind. You should never see a variable show up in that expression. So we're looking for the coefficients. So a is the coefficient in front of the x squared term. So looking at the x squared term here, this coefficient is 1. So a equals 1 here. B is the coefficient in front of the x term. So that's right here, which is 8. And c is the constant. In other words, it's the number without a variable. So c equals 12. All right, let's take a look at part B here. So again, coefficient A in front of the x squared term is 1. Coefficient B in front of the x term is negative 10. So we got to bring that sign that in front of the term with it. And the coefficient C here is negative 24. Makes a big difference when those coefficients are negative, mathematically, right? Okay, looking at C here, coefficient A is 2. A little sloppy there. There we go. Coefficient B is 7, and coefficient C is 3. Notice I'm underlining the pluses, but when they're positive, you don't need to bring those signs with you. So this is what I recommend. This is very calculator based, and what I recommend is as kind of the template that you see below in A and B here, and that is, although I don't really care about the brackets out here, I know they have them in the template, and I could go either way on those brackets. I think it's a must to put the brackets here, because if B is negative and you square it, it ends up being a positive, and it's a must to put them here. Also a must to put them here, but the calculation in the denominator we're going to do by itself anyway. Okay, so let's look at this first one, A, and I'd like it just to identify it. So I like to identify A and B and C. So A is 1, and B is 8, and C is 12. And so we're going to put 8 in here. So we have the opposite. If we look at the equation here, it's the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. So here's the opposite of B, plus or minus B squared minus 4 times A times C all over 2 times A. Okay, it says now simplify. So what I would say is that item under the square root, we are going to do that value all in one. So we're going to take, let me just highlight that. We're going to take all of this and do it on the calculator. So what we're going to have is we're going to have x equals minus 8 plus or minus the square root of, and now we're going to do that math. We're going to go 8 squared, bracket 8 squared minus 4 times A times C. And notice when I'm using my brackets on my graphing calculator, I'm not putting the times sign in there. So this is equal to 16. I could put the times sign in there. So, whoops. Clear that out. If I redid this calculation, I could do 4 times A times C. I could put those multiplication signs in there. I'd still get the same answer. So I just don't, because it leads to the same answer. Okay, and then in my head, I'm going to do this, right? 2 times 1, that's easy enough to do in your head. So that's 2. So that's the simplification, and now that leads to 2 answers. So that leads to x equals minus 8 plus, and then the square root of 16. If you don't know the square root of 16, go ahead on your calculator and type it in. It's 4. So 8 plus 4 over 2. And x equals negative 8 minus 4 over 2. Okay, and then if we're going to do this part on a calculator, then what we need here are brackets. Okay, because we have to, a fraction is nothing more than the grouping operation. So you can do that, minus 8 plus 4. And then divided by 2. That's what it's going to look like on your calculator. That's negative 2. And then same here. We're going to need those brackets. Notice that when I put in negative 8, I'm using the negative sign that's down by the decimal point. And then when I subtract 4, I'm using the subtract key next to the 6. And notice how they look different. The negative key is short in front of the 8. That's right here. And the minus sign is longer in front of the 4. Okay, put my bracket in, divide that by 2. And so this is -6. So my two answers are -2 and -6. Those are the two answers that make that quadratic equal to 0. Okay, so let's identify, get rid of those arrows. Let's identify A, B, and C on this next example, and then go ahead and pause the video and try to do the calculations on your own. Okay, so A is that number in front of the x squared term, which is 1. Remember, these are always numbers. B is -10, and C is -24. Notice this, this is the same B that we've been working on, so you know what the answers should be, because we've worked this question twice already. Right, different technique, but should lead to the same answer. Okay, go ahead and pause the video and use the template below to find the two answers. And then restart the video to check your solution. Okay, if you're listening to me again, I'm assuming you've attempted this on your own. So we use our template here. We put B in, which is -10, and B here, -10 squared. That's where the bracket's going to be super important. Same with over here. A is 1, C is -24, and all over 2 times A, which is 1. So this is going to be x equals, and then I'm going to look at this minus -10. So I look at that, and I think in my brain, I think, let's get the brain out here. So in that part of the equation, it's minus a -10. I think opposite -10. So the opposite of a -10 is a positive 10. So I just write 10 here, plus or minus the square root of, and then my calculator is going to do the stuff underneath the radical. So I get my bracket out, -10. Remember that negative is next to the decimal point. Squared. Whoops, I hit the wrong key there. Doggone it. Let's try that again. Okay, -10 squared. There we go. Minus 4 times A, which is 1, times C, which is -24. Look at that, I hit the decimal point. There we go, -24. And that is 196. All over 2 times 1. Again, this I'm doing in my head. 2 times 1 is 2. Okay. And so that's going to give me two answers here. That's going to give me x equals 10 plus, I don't know the square root of 196. So I'm going to put in square root 196. It's 14. 10 plus 14 all over 2, and x equals 10 minus 14 all over 2. So notice that plus minus. We've seen that plus minus on the square rooting technique, and that's where it comes from. And looks like I need to scooch this over just a little bit. Okay, there we go. So 10 plus 14, I know it's 24. 24 divided by 2 is that 12, right? Remember, we've worked this question a couple times before. I'm going to scoot this whole thing over a little bit. And then 10 minus 14, that's -4, divided by 2 is -2. There are those two answers again, at 12 and -2. Okay, so hopefully that gives you a little bit of comfort with that. If you want to try question C one more time, setting up the template yourself, pause the video and go ahead and give that an attempt. I'm going to let you identify A, B, and C on your own. Then you can start the video again and see how you did on that solution as you're kind of gaining some independence on this. Okay, if you're tuning back in, I'm going to go through that solution for C. So in C, here's my A. My A is equal to 2. My B is equal to 7. My C is equal to 3. I'm going to do a quick pause here. Yes, they're all positive. Didn't miss a minus sign anywhere. And then I'm going to go ahead and set up my quadratic formula. So opposite of B plus or minus the square root of B squared, 7 squared minus 4 times A, which is 2, times C, which is 3, all over 2 times A, which is 2. There we go. And so that equals, looking here, opposite 7 is negative 7, so I'm just going to write negative 7, and plus. And now I need to do that on my calculator, plus or minus, excuse me, the square root of, all right, so we've got 7 squared, try that again, 7 squared, there we go, minus 4 times A, which is 2, times C, which is 3, there we go, and that is 25. All over 2 times A, I'm going to do that in my head, 2 times 2 is 4. So my answers then are x equals minus 7 plus square root of 25. If you don't know it, go ahead and quickly type it into your calculator. If you are trying to do this without a calculator, just think in your head what times what equals 25, right? Number times itself, and we get 5. So 7 plus 5 over 4. It's the first solution. And then the second solution is minus 7 minus 5 over 4. And then we can put those in. So minus 7 plus 5 divided by 4 is going to give us a decimal, right? It's going to give us a negative 1/2, right? The top is negative 2. That it could also be negative 0.5. And negative 7 minus 5 should give us a negative 12. Dividing that by 4 should give us a negative 3. Should give us a negative 12. I think I said just 12. So there's the two answers for part C. So as far as the learning target goes, for this section, the learning target basically takes you back to that quadratic formula. So put my calculator away right now. So whether you write a learning target down here or refer back to your notes if your notes are really good, we just need to make sure that we can locate that quadratic formula real quickly. So, and this is, of course, quadratics in standard form. The ax squared plus bx plus c equals 0. And then the solution then is that opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then just some quick tips. First tip is make sure we have it equal to 0, and then we've identified a and b and c values. Substitute in using parentheses. Oops, parentheses, and then simplify. Just to give you some tips there. Okay, so you've got a couple of questions that you can check your understanding on, and then you can check the solutions in your notes. Actually, it's easy enough for me. I'm looking at the answers right now. You should get x equals 9 and x equals negative 5 here. Wow, sloppy handwriting. try that again. X equals -5. There we go. You should get x equals 2/3 here, and x equals -7. And then this one, it won't have a perfect square. So when we don't have a perfect square, you can either leave it in this form, x equals 7 plus the square root of 37 all over 6, and x equals 7 minus the square root of 37 all over 6. Or you can actually give that in decimal form. And it's good to practice getting this in decimal form. So it would look like 7 plus the square root of 37. Whoops, and I think I need to get rid of that and go out here and put the bracket there. There we go. I'll get a little tricky with the bracket and the square root divided by 6. And that's 2.18. 2.180. Let's go 3 decimal places. It's a good number. And then I'm going to do something called a second entry. So I hit the second key, and then I go in the lower right-hand corner and hit entry. It gives me my expression back, and then I can just come back here and put in the minus sign. And then the next one is 0. We always want to lead with a 0 if the answer is a decimal between 0 and 1. So leading 0, 0.153 would be 3 decimal places correctly rounded. So it's always good to kind of practice getting those in decimal form when we don't have perfect squares, right? If that were a square root of 36, then it would work out really nicely. Okay, so you can practice those and to check your understanding if you feel like you need some extra practice. And then you can go on to the quadratic formula homework, which is those questions, and you can see a couple of questions down there that don't have perfect squares. And I think I updated those answers too. Let me give you the decimal answers just for quick reference here. Let's see, those all turned out okay. This one the answers would be 1.545 and -1.295 if you want decimal answers. And this one would be, oh shoot. These are this question. There we go. This question is 1.771 and -1.271. And let's see here, number 10, 1.081 and -2.081. And do we have any more? Nope, that's it. I think those are the only 3 that didn't have perfect squares, so the radical didn't. Yep, those are the only 3. So there's your decimal answers too. That will give you an opportunity to practice those decimals.